I'll get started. Hey, good afternoon, everyone. My name is Monica Drickers. I'm the Senior Program Director for the Massachusetts Rivers Alliance, and I'm joined today by my colleagues, Robert Kearns of the Charles River Watershed Association, and Anna Renkert, who is my teammate here at Mass Rivers. It's March 6, 2024, and I'm delighted to welcome you to the Dam Busters 101 webinar series. It's a collaboration between the Mass Rivers Alliance, the Charles River Watershed Association, and the Mass Division of Ecological Restoration. This webinar series offers basic information about dam removal to managers from municipalities and nonprofits that may be considering such projects in the future. Please note that the series is not intended to advocate for the removal of any particular dam or dams. For the series topics and exact schedule, please visit the Mass Rivers Alliance website at www.massriversalliance.org. Today's webinar is an overview of engineering and design. Please mark your calendars for the next webinar, which is about addressing infrastructure, and that will be held on April 3rd at noon. A few housekeeping items. First, this session is scheduled to end at 1 p.m. Second, please put your questions either in the Q&A feature, which you'll see at the bottom of the screen, or hold them until the last half hour's Q&A session. Robert will be monitoring the questions as they come in, and he'll MC the Q&A session. Third, note that these webinars are being recorded. Recordings and any other webinar materials will be made available on the Mass Rivers website. Lastly, we ask that you please complete the evaluation survey that will be sent to you after the webinar. It really helps us as we plan to continue the series. And now I'm really delighted to introduce today's speaker, Nick Nelson. Nick is a fluvial geomorphologist and Northeast Regional Director for Interfluve, a river and wetland restoration firm. For over 15 years, Nick has been working on dam removal and other river and wetland restoration projects throughout the Commonwealth and the nation, beginning with the evaluation of multiple dams on the Mill River in Taunton and the Shawsheen River in Andover. Nick has helped to evaluate, design, permit, monitor construction, and provide post-construction monitoring for over a dozen removal projects in Massachusetts. And with that, I will hand it over to Nick.
Great. Thank you very much. And thanks all for joining. I see a lot of familiar names and faces. So it's good to see friends and colleagues, past and present. I'm just going to share my screen here and make sure we're in the right mode. Switch this around. Okay. Can you give me a thumbs up, Robert or Anna? Okay, gotcha. Great. Thank you all. My plan here is to chat for about 30 minutes or so and then leave plenty of time for questions and discussion after that. This is a big topic, so I want to start with a couple of caveats. As it was mentioned in my introduction, I'm a fluvial geomorphologist. I'm not an engineer. I work for Interfluve, which is a river and wetland restoration company that has done a lot of dam removal projects across the country. And we have a number of engineers, so I work with our engineers on these engineering projects. What I speak about today is based on my experience on projects and my experience collaborating with many of you and others in the region and around the country. But many other engineering firms do a lot of this work as well and have similar experiences or might have varied experiences. So just keep that in mind. This is one person's experience with the dam removal process from the engineering standpoint. To start, we know that rivers connect in a lot of different ways. Upstream, downstream, across the floodplain, across your channel cross section, culturally, spiritually, we feel connected to rivers, and dams disrupt this connection. So you've had previous sessions of intros to dams that other folks have done in earlier Dam Busters sessions. I'm not going to rehash all of that. But this is why we are getting into this engineering section here, is to reconnect our river systems. And want to emphasize that this is our opportunity. We have a lot of opportunity to make improvements and correct some of the issues that we have caused on our landscape. So I love this quote from Ramona. And I think this is particularly relevant when we are talking about engineering and designing rivers and designing a dam removal and thinking about designing wetlands or floodplains or stream habitat, all of those things that we love doing and that we can do to kind of jumpstart these systems again. But needing to recognize that this is natural world, these are natural systems that we are living within and amongst, and being in that space with humility, I think is really important. Can't be too overly confident in what we as humans can do in this landscape. So I'm going to run through a few things here, and again, way too short a time to get into all the details of what you need to know for designing these projects. But I'll run through some typical assessment and data collection methods and tools, typical data analyses that are necessary, typical design process, and then some of the construction challenges and sort of construction observation period things that we typically go through. A couple of take-home messages to start here. Rivers are complex. You all know that. We know that. There's a lot of different elements that go into understanding rivers and by way of that, dam removals as well. And the due diligence is critical. I think we've certainly seen, I've seen, many of you have probably seen some pretty simple, what seem like simple dams, small dams in areas that feel like, all right, just pop these things out, we're good to go. From an engineering standpoint, the due diligence is really critical for us. Engineering, our engineers have licenses that require that they go through due diligence. We as engineering firms require that we go through this due diligence to make sure that we're sort of following best practices and doing the best we can to understand these systems. At the same time, uncertainty is real. And when you're dealing with rivers and you're dealing with dams that have impounded rivers for hundreds of years, there's uncertainty. You can't know everything that's happening underneath that dam and underneath that impoundment, regardless of how much you study it or survey it. There could be surprises that come up. And then, oftentimes we think of the construction period as being the restoration, but really that is just the very beginning. And that's at that point that we can start to see the restoration recovery of the landscapes. So I mentioned rivers are complex. There are lots of different disciplines that are required to understand rivers, understand how rivers interact with the floodplains, understand how we can think about removing a dam in a safe manner. These are some elements that might come into play. There might be a dozen others for a particular project. Some projects might only have 3 or 4 of these, but recognizing that no single person, as a geomorphologist, I can't know all of these things. And so having a team together that understands the different elements of what's required for your particular dam removal is really important. If one person is coming to you and saying that they know everything that there is to know to take out your dam, I'd be pretty skeptical of that. I have not found a person that has all of that information in their head. And there's a lot that goes into sort of the initial data analysis and data collection. And so I'll start with this idea of forensic geomorphology. As a geomorphologist, I might be biased, but I sort of think that geomorphology is the framework in which everything else comes. But I know ecologists think otherwise and engineers think otherwise, and I respect that as well. But forensic geomorphology we find to be really important to understand where the river has been in the past, what the history of that river is, and what the human history and impacts have been, and what the trajectory is going to be. That requires a lot of investigations, field investigations, office investigations, study of historical maps, study of historical air photos, historical documents that might have text that talks about these rivers and dams back in the 1600s. There is some great documentation in the 1600s of conversations that were happening in Taunton about whether or not to build dams on the Mill River. They'd seen dams go up elsewhere and seen the catastrophic impact to the herring. And so that was a conversation that was happening that is documented in the 1600s there, which is pretty neat to see. But those maps can be really helpful in understanding what these rivers used to look like. But critical also to remember that that's not necessarily what this river is going to be in the future. But it's still really helpful to understand what it was and what the trajectory is. At the same time, habitat assessments are really important as well. Again, depending on the dam, depending on the complexity, and depending on what that particular dam and river is showing, habitat assessment might be helpful. You might need to be thinking about critical fish species and what habitat is in the river outside of the dam and impoundment area, so that you can think about what types of habitat design you might want to incorporate in your dam removal design. Maybe that's a critical piece of it. Maybe there's a wetland delineation that needs to happen. That's part of this. Maybe there's a botanical survey or a rare species survey or general, floodplain habitat assessment as well. Those two assessments typically go pretty well together, the geomorphology and habitat assessment. And then there's a lot of surveys, topographic surveys that can happen. What I like about this image here is it shows a really old total station. So this dates the picture. There are more sophisticated units that we use now, which are pretty fun. Also shows a really young colleague that I have out there, Marty Melcher. So this was many years ago on the Mill River at Whittington Dam in Taunton. And the other elements of this that are pretty interesting is that you can see evidence of the former floodplain. So you can see those stumps emerging from the impoundment. So this is part of that forensic geomorphology, but also part of the survey. We can see where this historic channel used to be in this particular impoundment. And we can start to begin to collect survey data. Topographic survey data is critical for the hydraulic modeling, which is critical for permitting and critical for designing. We can survey the vegetation, changes in vegetation, the ordinary high water marks, different types of features that are critical for the regulatory entities and regulated resource areas. If there's a wetland delineation, that can be surveyed in at the same time. You might survey in different features that you see, like the stumps or boulders or riffles that you might see within the stream system. And you need to think about the extent of your survey. Survey the impoundment. You need to survey cross sections through that area to better understand the hydraulics through there once you run your model, but also downstream of the dam and upstream of the impoundment. Those are critical surveys to understand what your channel geometry might be that you might be designing for. Another critical assessment piece is the impounded sediment. Impounded sediment can sometimes be a deal breaker. If it's not a deal breaker, it can certainly be a complication or could be a significant cost factor. So it's really critical at an early stage to understand the quantity and quality of that impounded sediment. Sometimes you can pull the dam out and release the sediment downstream. Sometimes you can't. So understanding the volume of that sediment, the texture of that sediment, it's muck or sand or something coarser, and the quality. What kinds of contaminants are within this impounded sediment? Is it cleaner or dirtier than what you're seeing elsewhere in the river system? All those elements are critical to be thinking about. And so we can measure that that sediment thickness by going out in a boat and probing through the impounded sediments. It's typically fine-grained sediment that's piled up, and we can poke through that and feel the harder surface underneath, which is the former floodplain or former channel. We call that the depth of refusal. And you can often, as you survey across these impoundments through New England, you can often figure out where that original channel bed was, which can be really helpful. And it can give you an indication of what substrate was in the channel bottom historically. But this allows you to measure the thickness of the sediment through the impoundment, and then bring that back to the office and calculate a volume of impounded sediment. There are certainly impoundments and systems that do not lend themselves to simple hand probing with a flexible rod like this. And just so you know, these are chimney sweep rods screwed together with tape put on there for every 1/10 of a foot. So you can measure that. So a pretty simple tool to get that you can order online and get any length of that together. But if you have impounded sediment that might be coarser sand and gravel, you can't do this. But you still might want to understand what that volume is. So there might be other tools, or they might have a bigger, deeper impoundment. So there's boat and barge-based vibrocores. There's GPR, ground penetrating radar, that can have some functionality, and other boat-based remote sensing that can get some of this information as well. Coring helps us to collect some samples to then send to a lab and understand the contamination that might be in there. There are many state licensed labs around that do these types of testing and analyzing, and they send you the bottles, and you put the sediment in the bottles and follow their directions, and then they run the test back at the lab. So a couple of things that we like to make sure of for this the sediment sampling is getting a full composite sample from the top of the sediment down to the refusal layer. So you're capturing that whole layer of sediment, the full thickness, and making sure we are working with the state agencies, the Department of Environmental Protection, sending them a sampling plan, getting some feedback, hopefully, to help guide that sampling plan and moving forwards. Typically, there are multiple rounds of sediment sampling required. This initial phase kind of gets you an idea of what contaminants might be there. And then if there are higher concentrations of some contaminants, you can zero in on those areas and get more detailed sampling, or depending on the designs, shift the next round of sampling as well to make sure you're understanding the quality of the material that either may be released downstream or might be removed for reuse somewhere else or disposed of in a landfill. So we come back to this in terms of thinking about the complexities of the field-based work and data collection, and in a similar way, we need all of these tools for the analyses as well. So that's what we're going to get into now. There are so many different types of analyses, engineering analyses, ecological analyses, geomorphic analyses to think about with dam removal and river restoration projects. Some of the big ones that we often think about right off the bat are understanding the hydrology. How much water is in the system? When does it flood? How often does it flood? What is the magnitude? What are the magnitudes of those floods? And then the hydraulic modeling. So there's typically in the past, HEC-RAS one-dimensional models were sort of the standard, and they still are the standard, but there's a lot more 2D and 3D modeling happening on rivers nowadays. It's become a lot more user-friendly and interesting to do and easier to do. But the basic gist of it is that we, through the hydraulic modeling, we can understand where the water goes at various flow levels under existing conditions and under proposed conditions. So those are really critical analyses to be run right off the bat. But there are so many other design studies and calculations. You need to figure out what size channel that you're going to build. If you can't just take out the dam and let the river go, you need to design the river channel. What's the size? What's the width? What's the depth? What are your bank slopes? What's the bed structure? Do you have a riffle pool system, or do you have a riffle run, or do you have more of a low gradient wetland stream system? What's the bed substrate like? Do you need to import some rounded stone to create riffles so that you don't create a head cut and migrate some erosion upstream? Do you need substrate that is sized appropriately to limit bank erosion and to limit bluff erosion? What's the bank design? Can you use large wood? Can you, and with that, how do you size that large wood? How big is it supposed to be? How do you prevent it from floating away? Or do you want it to float away? Those are all decisions that you need to make. Fabric encapsulated soil lifts, the biodegradable fabric with the soil in there and seed and plantings. When is that appropriate to use? When is it not appropriate? Maybe you need to use riprap or more angular stone. What is the appropriate bank design for this particular site? We don't need channel dimensions twice. I already mentioned that. Floodplain width. How big is your floodplain? That's a design consideration. Aquatic habitat design. Do you have pools? Do you have riffles? Are you designing for certain spawning substrate? Backwater habitat for rearing for certain fish? Mussel habitat? Many different things to think about. Floodplain habitat features, planting designs, scour analysis if there's infrastructure around. So you can see that as we add all of this together, traditional ecological knowledge on paper, so people can see what you are thinking about. And typically the design process includes a few different deliverables. In broad terms, you have design drawings, you have a basis of design report, which explains everything that you've done, the analyses that you've completed, the data you've collected, and explains why you are doing the designs that you've suggested. There might be other elements of that, like a sediment management plan, a traffic control plan. There might be other plans in there that can be lumped in there or would be appendices, certainly. And then there's the engineer's opinion of probable costs. So this is the estimate of construction costs. And these are done, all of these elements are done at the different levels of design. So there are conceptual renderings where there's really no engineering design yet, but it's sort of this artistic idea of what the site can look like. There's 25 to 50% complete designs. And what's a little bit challenging for you and for me and for everybody is that everybody has a different level of design that they want or that they think they want, or has a different idea of what 40% design is or what 75% design is. And so it's a little bit hard to compare sometimes. But in general, you can envision that a 50% engineered plan set has gone through a good chunk of the engineering, have a pretty good sense of what's happening, but there's still a lot of refining to do after that. Still a bunch of checking calculations, potentially some changes in the designs a little bit, and refining of the plan set. And then for certain projects, you might go from concepts straight to 75% and then straight to 100%. For other projects that are more complex, you might need 3, 4, 5 levels of designs to get full buy-in and review from all the different entities involved. So I put all of these in here, not to suggest that you need all of these levels for every project, but that there are different levels that are typically necessary for a project. So for this particular one in Norwood, this is on Trap Hole Brook, Mill Pond Dam Removal. Did some conceptual renderings and plan view. Gives you a broad brush idea of what it might look like. You could do these sidelong views, cross sections, or oblique views as well. again, gives homeowners, gives the public a pretty good idea of what it might look like and kind of a visual of that. Also, examples of other projects really help for this also. If you can show examples of former projects that have already been completed, that's super helpful. And then 40% design might have a plan sheet. You might have, a number of design sheets that go together. I just pulled one out here to compare across a few different levels of design here. So you can see there's some designing here, there's some engineering, there's some proposed contour lines, there's cross sections that are cut through here, there's a longitudinal profile on the bottom of the sheet. You can see some areas where we've suggested constructed pools in the blue, other areas of fabric and bank treatments in the green and the yellow. And then when we get towards 75% designs, you can see there's a little bit more of a wiggle in the stream pattern, okay? We've refined that a little bit more. We can see the pools are a little bit more defined. We can see some stone in the riffles in between. We can see areas where there's some large wood proposed. We can see trees to be preserved and trees to be removed and salvaged. And then in final designs, the alignment is pretty similar, but we see a little bit more detail in terms of the longitudinal profile and the materials that are in that material legend element right in the middle of your screen here. So a bit more detail there. So at each level of design, you add a bit more refining. What you're trying to do by the end here is get a plan set that the contractor can read and the contractor can understand to implement that work. And so it has to be clear, has to be concise, has to be understandable and translatable by a contractor. Construction cost estimate is a really critical piece as well through all of those different phases so that the project partners, you all can think about raising funds for the project. It's pretty rare for a project to have all the budget for construction right from the beginning. Typically, you are raising money throughout the process. And so I'll point out a couple of things here that I think is important when reviewing these. Up in the upper left hand, we're talking about 2021 dollars. So remember, especially during COVID, and especially in recent years, costs have increased much higher than they had prior to 2019, 2020. So there's an escalation each year that is more than it typically had been prior to that period. And so you need to keep that in mind in terms of when the project will actually be constructed. The type here is the unit type. So cubic yards or each boulder or tons of stone, square yards, that type of thing is important to keep in mind. And then also you might have a number of different contingencies. This is the construction contingency down at the bottom. This 10%, that means you're at 100% estimate here, and you feel pretty confident. That's a really high level of confidence here. Concept level, that could be 50 to 100% contingency if you're at the concept level of design. If you're at that sort of 25%, it could be 30 to 50% contingency. So you really want to be careful to not attach a level of precision to this estimate that is not based on the level of design. Okay, so moving through all the assessments, analyses, and designs and into construction. This is the fun part. You've got years of planning put together and designs, and you're finally into construction. How does this actually happen? While it seems exciting to use explosives to remove dams, and it has been done. You can see the Condit Dam removal in the White Salmon River in Washington. Watch this video, it's amazing. They used explosives to create a hole in the bottom of the dam, and it just released a torrent of water and sediment, and you can watch this time lapse, which is incredible. This is not possible in most places. So recognize that this was a kind of a unique situation. But there are other ways of removing dams. Big dams out west, the Elwha dam removal, that looks pretty scary to be on that excavator, hundreds of feet above the valley bottom. But that was how they were able to remove this one, from the top down, chiseling away as the impoundment drew down. This is typically what we see in Massachusetts, smaller dam removals where you have developed some water control to move the water around, and you're removing a small concrete structure. There's a lot that goes into figuring out how to actually do this. And that's, some of that is engineering and project partner team, but a lot of it's on the contractor to figure out the logistics. I'm going to go through a couple of slides here of common challenges. One in particular is access, and I think I saw Chris Hool in the attendee list here. This was his picture for the Balmoral Dam on the Shawshene River. This was a case where the walls on either side of the dam here in the river were considered historic and could not be touched. So we couldn't cut through those walls. And so the excavator had to be lifted into the river, into a place that was walled off by a porta dam. And they had to do all the work from inside the river. So that was challenging. Dealing with that water control, which you can see on the right here in that same site, was really challenging. A lot of pumps to keep that area dewatered. So pretty tricky. Water control is a really tricky component of dam removal projects. Image on the left is a bypass channel around the excavation area. Really tricky here as well. They lined it with some plastic. Storm events blew that out once. So it's really tricky to get that just right so that stays in place. So really kind of challenging to figure out the water control for some projects. Sometimes you can work right at the dam and just move the water from one side to the other. In other cases, you need more control like this. Some of the bigger challenges are people. We have had trucks try to drive out on the impoundment overnight or on weekends. ATVs driving out on former impoundments and just getting stuck. Don't recommend it. We have active construction sites where there's lots of project partners that want to see the work. Getting them to the site in a safe manner can be challenging sometimes. You might have private landowners that present a risk. We've had private landowners that are threatening the contractors and threatening project partners. So people can be a challenging element of these projects. And sediment management is a big one. And a lot of analysis and discussion goes into this, and coordination with regulatory agencies. There, typically in Massachusetts, we have a lot of active management where we're removing sediment, but this is costly. It also allows you to develop a stream channel right away and develop habitat right away, which is great, but it is costly and also removes what might be important sediment from downstream reaches for habitat, for floodplain reconnection, for salt marsh development, that sort of thing. So passive sediment release is another option and has been done throughout the region, throughout the country. But it requires a lot of analysis and figuring out if that is possible with the sediment that you have. Got to figure out if you're going to impact infrastructure upstream or downstream. So that's critical to think about. This is that conduit dam removal that we showed earlier with the explosive removal. That flows into the Columbia River. A huge delta developed, lots of sediment going in there, which the Columbia River could handle. But you can see in these images in 2016, 2018, and 2021, where the sediment has been accumulating along the sides and then vegetating up over time. So the channel is changing, the channel is recovering. Then there's creative solutions. This is one out west on the San Clemente Dam on the Carmel River in California, where they actually blasted through a bit of a mountain to just bypass the whole impounded sediment entirely, and to connect with a tributary channel, because there was 90 feet of sediment that had accumulated. Construction observation is critical to help the contractors interpret the design drawings. try to respond to questions that might come up, be a liaison for the owner. But that relationship is different for every project depending on what the owner and project partners need. So recognize that the engineering firm can take on a number of different roles with the construction period. And I will end and open this up for questions, but just to say that when we're working with dams and rivers, they will be highly engineered restoration projects, but they don't have to look engineered once the project is completed. And with that, I'll stop my share and open up for questions.
Awesome. Thank you so much, Nick, for your presentation. We have a lot of questions in the chat and the Q&A. The first question we have is from Anne, who asked, for sediment analysis, do you typically take lab samples of the sediment upstream and downstream of the impoundment for contamination comparison?
Yes, great question. Yes, short answer is yes. And then the next question is, well, how many? And that sometimes depends on the situation and the volume of sediment in the impoundment. We would typically take 1 to 3 samples upstream of the impoundment in depositional zones, and the same downstream of the impoundment. So yes, absolutely. That really helps everybody understand what the background contamination is in the river system.
Thank you. The next question is from Allison. What is the cost range for sediment core sample analysis?
Typically for Massachusetts permitting, the suite of analyses, which I'm not going to list all of them, but typically include PCBs, volatile organic compounds. You might have organochlorine pesticides in some cases, heavy metals, and a few others in there. That will typically range from $1,000 to $1,500 per sample. That would include grain size as well. Certainly, as I'm sure many of you are aware, PFAS has entered our lives as something that at times needs to be accounted for. So that is another element that would get tacked onto that. And I think that's in the order of $300 to $600 per sample, just the analytical fees for that. But depends on the lab.
Thank you, Nick. All right, the next question in the chat is from Dan, who asks, do you typically engage an LSP or licensed site professional to administer the sediment management plan? And do you sample the sediment based on what local disposal facilities would require?
Yeah, really good questions. I'd say it depends. So for many of our projects, we have not needed to engage with a licensed site professional. Sampling protocols and the analyses and working through a sediment management plan with the state regulatory entities have gone on without that. But if there are some cases where things are a bit more complex, where there might be higher levels of contaminant concentrations or some complexities with potential reuse, then definitely a good idea to bring those folks in and bring in their area of expertise. So they are a critical piece to rivers and dam removals. Definitely use them when appropriate for a particular project. What was the second part of that question again?
Second part was, do you do sample the sediment based on what local disposal facilities would require?
Right. First of all, we typically sample for what is required for permitting. And then if there's a need to remove the sediment off-site and dispose of it in a disposal facility, then that's typically the final round of sampling that is done, is because they need, typically landfills need recent analytical results within the last several months or 6 months. And so the sampling that you did 3 years ago when you were first analyzing the site really isn't relevant for them. And so, yes, at that point, then you would do a few other analyses that those landfills would typically require, and that would be landfill specific.
Thank you. All right, the next one has, from Ed, the relative close abundant rock placement below the Shawshene River in Andover, Massachusetts, dam removal is a hazard for recreational boating. Recreational boating access was intended in the project planning, but fish took precedence when I inquired about it during construction. Can recreational passage be consistent with fish access?
Yes, and I'll say that I have canoed that riffle a few different times, and it's a great little paddle through there. Not for everybody, certainly, but it is accessible. That particular riffle there was not built for fish passage. That riffle was built with fish passage in mind, but had to be developed because there was underground utilities underneath that bridge. And so that needed to be protected with the riffle that was constructed there. So a little bit bigger than what the Shawshene River likely had prior to human involvement here, but within the slope range for fish and allowed that infrastructure to have some stability.
Thank you. And I bet depending on two flows, probably the paddling would change.
Yeah. I guess to expand on that, I think that is statewide, recreation depends on flow volumes. We have many rivers that are unaccessible during summer flows because the water is too low, or during spring flows because the water is too high. So when these dams come out, you are back to a system that is flowing by the seasons, and every year is different, every season is different, and every person's ability is different for that recreation.
Yeah. All right, the next question is from Heather. She asks, are there guidelines listed anywhere for thresholds that will determine whether you will have active or passive sediment removal?
Yes, I believe that there are some documents that provide a bit of a flow structure. I believe the Massachusetts Division of Ecological Restoration may have sort of a flow chart for that type of thing. There are, at the same time, everything is very case dependent and site specific and based on goals and project partners. That flow chart is in part looking at contamination levels. If contaminants are high and exceed human health thresholds. So the State Department of Environmental Protection has human health thresholds for contaminants. So that's one level of criteria there. But then the other piece is, even if it's clean, if it's a lot of sediment and might impact infrastructure somewhere, then that's part of that flow chart as well. So I won't be able to give you like a website right now or a document name, but there are those resources out there that you can reach out afterwards or reach out to the Division of Ecological Restoration, and they likely have those documents.
Thank you, Nick. The next question is, at what stage of the removal are renderings done for what area will look like after the dam is removed? I find that most people need that visualization.
Yes, it's been helpful for us at different stages. I think at the very beginning, kind of conceptual stage is a great time to do it when you're initially engaging the community and suggesting what might be possible out there. That is super helpful and really helpful to pair that with photos of other dam removal projects that has happened, so you can see exactly what it looked like. And then it's good to bring that back in later through designs also with later public meetings. Because when you show design plans at, say, a public hearing for the notice of intent at a town, there's a lot of engineering details in there that are hard to understand. And so sometimes it's good to pair that with a reminder of the conceptual rendering of what it looks like.
So thank you. All right, the next question is from Anne, who asks, if a good geomorphological reference reach cannot be found on the same river as the dam removal due to human interference, what are your parameters for selecting a separate reach reference in a more undisturbed area? It's the first part of the questions, and then I'll say the other part is, are there good local publications with reference reach data by watershed size or bankable cross-section area? Those a lot. Maybe bring it up.
Yeah, great questions. We find this a lot in New England where our rivers are so impacted that it's hard to find a section of river that is relatively unimpacted. So what we will sometimes do is if you can't find a reach up or downstream, maybe there's a nearby watershed that is of similar size, a nearby river that is of similar size that has less impacted zones that you can kind of get a sense of what the channel dimensions might be or what that river might have looked like. And then going back in time through those maps or aerial photographs. Unfortunately, many of our dams were done before, air photos and maps, so that's pretty tricky also. But again, there are typically other watersheds or river systems nearby that we can use for that. And then kind of using the different elements of the stream to help you figure out channel dimensions and engineering designs, understanding the slope with the constraints that you have within your site and the constraints that you might have along the edges in terms of infrastructure and that sort of thing. Typically, you can pull those different lines of evidence for that. There's, in terms of tools, I think a lot of folks have used USGS StreamStats as a tool in areas that where there's not great gauge data. That the USGS StreamStats uses gauge data in many locations, but in other areas it uses estimates and relationships. That is a good tool to begin to think about your river system, but there are other calculations as well. And so I guess what I would suggest is that there are kind of multiple lines of evidence that you try to bring together, and hopefully they converge into a channel dimension and a design that works.
So thank you. Looks like we still have some more time. If people still have additional questions, feel free to put it in the Q&A of the chat.
And Anne, I saw you come off or come on to video. So if there's anything else that you wanted to add to that question.
Yeah, that's great answer, and thank you.
Yeah, and I think more and more there are guidelines, there are sort of reference books and articles out there, much more so than there were when we first started out doing this. So there's more resources out there.
Does anybody have any burning questions? Just monitoring the chat and the Q&A. Want to thank everybody for coming too. It's really was an abundant meeting. We had, I think we clocked over 82 people. Oh, we have some more questions coming in. Great. Has Mass DER compiled a database of recent dam removals for design reference?
Great question. I'm searching through the names to see if we have anybody from DER on. I think the summary, I believe they are collecting that information. Allison, did you just come off mute? Yeah. I can't hear you.
There we go.
There it
Hi,
is.
everyone. First, let me just reference back to the DR guidance on active and passive. I just sent a chat to try to acquire that information, and I'll share it with Mass Rivers if we locate that it's external facing. And then to answer the question about the compiled database of recent dam removals, we do try to keep our website up to date with the ongoing projects that are happening. So you can often go there. They don't have, in terms of design reference, it shows you the location, but we don't typically like share out the designs themselves, but you're definitely welcome to go visit those sites. They're quite stunning to see even 1 year out.
Perfect. And I will add to that, I think, and correct me if I'm wrong, Allison, you've also been kind of comparing costs of dam removals across the years and regions to sort of try to get a better sense of what to anticipate for, you know, a certain size dam in a certain area. And I don't think that's sort of public facing to be published, but it's something that I think in particular projects, if DER is a partner, it's often something that the DER staff member can weigh in on and provide some background information on.
Yeah, that's absolutely true, especially because the costs are kind of rising, but there's also a lot of shared learning that's happening too. So that's helping and permitting continually changes. I think DER has developed or starting to develop a technical services branch, which hopes to kind of bring that information, all the information that DER has, which is an incredible amount, to the public in different ways to help advance these projects. But that's kind of just beginning, but we will definitely, that we recognize that that's one of the biggest questions that people have is how do we even estimate for early grant writing to understand before we even have the consultants on? That's really key. And so we acknowledge that need, and we're working with our technical services to eventually have that for the public.
Yeah, that's great. I see, Robert, you added a link into the chat, and I followed with another American Rivers link as well. American Rivers is another great resource. They have a map of dam removals, but they also have a database of the dams removed. So you can kind of see location, size, date of removal. I think they might have cost of designs and cost of construction as well. And staff at American Rivers are really helpful with that information as well. So they kind of have been working nationally on a lot of different dam removals and are a really great resource as well. And I see the other question about publishing data on fisheries and other restoration outcomes. Yeah, I think a similar vein to what Allison was saying. And thanks for putting that link in the chat, Allison, with the DER ongoing projects. In general, when I first started getting involved in this in the early 2000s, and the first few dams were coming out, there was very little monitoring done, very little funding for monitoring. Now there's a lot more of that, but the compilation of that and sort of understanding of all of that together on a regional scale is really lacking, I think, and that's not unique to Massachusetts. It's sort of nationwide, that there's not a lot of good information out there that has compiled all of that post dam removal or river restoration information. It's getting better. Yeah.
Thanks
Go ahead,
again, Allison. The other thing I want to mention on American Rivers is if I know some municipalities who may be online and people in the engineering side, if you have projects, feel free to give that information to American Rivers, add to the database. They always reach out to folks like watershed groups to get new information for the database and such. So great to share information. We do have another question in the Q&A from John asking what should we be asking that we haven't? What new topics come to mind to you as you're responding to all these questions today?
That's a good one. I think if you have dams in mind that you're considering, I think whenever I think about these projects, typically the engineering and design, that's sort of a known entity for engineering firms. Those are things that we can work through. The human element of community discussions and involvement of community members and getting support for projects, that's a challenging one that engineering firms who come from not that town or not even that state aren't, sometimes are not best to present that. So it's a delicate balance sometimes there where we need to be able to present technical information to a lay audience in a way that's digestible. And oftentimes the project partners can be really, really helpful in that. So developing a project partner group, I think, is really critical. Understanding, what goals and objectives those different project partners have. A large project partner group can be challenging for a project manager to wrangle and to kind of move in the right direction because everybody has different views and thoughts on the process. But it also means that you have technical experts and you have funding opportunities in different realms. So I'll just put that out there as sort of the non-technical side is a really critical element that is sometimes left out when somebody's first thinking about a project.
Nick, we have one more question maybe we could squeeze in. I know we're running out of time. David asked, when a dam or weir cannot be easily removed, can they be reduced in scale for partial restoration?
Yeah, that's a great one. And I think there are multiple other avenues that you can go for improving that situation. And it depends on what the goals are. It depends on the adjacent infrastructure. Yes, if you can remove a portion of the dam, but you need to keep some of it because of a utility line upstream or something like that. Maybe that's necessary. Or maybe you can reconsider how you can protect that utility upstream or move it. Sometimes dams can't come out. Big Penobscot River restoration up in Maine, the Howland Dam, that had to stay in place because the town required it. And that was sort of the linchpin for the whole restoration. So a giant bypass channel was built around it. Not ideal when you think about, hydraulic movement and connectivity, but that is passing fish just like it was as if the dam wasn't there. So talking to agency staff there, they believe the fish see that as just a river and they go right around that dam. So there are bypass channels, there's lowering, there's sort of riffles that you can create to step up to the level of the dam and get fish up and over. But kind of depends on what those overall goals are.
Thank you, Nick. And thank you everybody for coming today. We are at time. I just want to thank everybody for coming and also let people know we have our next dam buses is April 3rd at noon Eastern. It's going to be addressing infrastructure. We will be sharing materials on the Mass River Alliance website, as well as a survey. And just want to thank everybody for coming. And this was a great presentation. And thank you, Nick.